Okay, in this video, we'll look at some properties and results on sets. To note it first, every set is a subset of itself. Okay, so if A is a set, then A definitely is a subset of itself. Okay, so every set is a subset of itself. You know, every set has two subset, at least two subsets. Now, which will be the second subset? We know that subset, itself, it would be a subset, right? And the other subset, the empty set phi. Okay, phi is also a subset of every set. So, phi is a subset of any set A or B for that matter. Okay. Another thing, if A and B are two equal sets, in case you have a question, you need to prove that two sets are equal, then what you need to do? You need to prove double containment. That is, A is completely contained in B and B is completely contained in A. If that happens, that would mean that's the only case when A actually equals to B. Okay? They both are completely contained in each other. Okay. Now, if A is contained in B and again B is contained in A, then A equals B. So this is like a two-way statement. So it's the same thing. Okay. Very important. If you have a set, if A contains n elements, okay, if any set A contains n element, then A has 2 to the power n number of subsets. Okay, it will have 2 to the power n number of subsets. Okay, what is a power set? In fact, from here we can look at what a power set would be. A power set essentially is the collection of all subsets of a set A. Okay, power set is collection of all subsets of a set. Okay, this is known as power set, which is denoted as, if A is the set, then PA is the power set. And how many elements it would have? How many elements it would have? A power set will have 2 to the power n elements in it, because these are the number of subsets of a set 2 to the power n, and that would make a power set. Okay, now some result on proper subsets. What is a proper subset? What is a proper subset? A proper subset means that there is complete containment. That is, if A is a subset of B, and you also know that A does not equal to B, then you say that A is a proper subset of B. Okay, and it can be written as A subset of B. Okay. Now no set. Now mind you, property that I would like to share is that no set is a proper subset of itself, right? Every set is a subset of itself, but it can't be a proper subset because it equals to itself, right? So that is there. Okay, and phi is always a proper subset of every set except itself, is always a proper subset of every set except for itself. Of course, it equals to itself. And yes, another very important point, phi has no proper subset, right? Because there cannot be anything smaller than phi. Okay. So phi has no proper subset. A set having n elements will have how many? A proper subset? A set having n elements, okay? N element set will have how many proper subset? 2n is the total number of subset it can have, and 1 is itself. So you take that out, that will make the number of proper subsets, right? Number of proper subsets.